Why do some appliances need a power plug? What is AC/DC current? And why are some batteries chargeable and some are not? Hi, I'm Adya Carol Baghel. I'm a student, an author, a vlogger and an aspiring astronomer. Together, let's try to understand the world of electricity around us. Under the International System of Measurement, the SI unit of electricity is Watt. Named after James Watt, the inventor of steam engines, 1 watt equals 1 ampere of current and 1 volt of force. To understand the relation between watt, ampere and volt, let us consider this pipe as a wire and the water as electricity. The amount of water, in which our case is the electricity, is measured in ampere. The pressure with which this electricity is passing through the pipe is measured in volt. The total electricity received is a product of ampere and volt and is measured in watt. All our appliances are ruled by these basic guidelines. The power chart of this AC indicates 2000 watts of electricity and 20 volts. This basically means if we run this AC for 1 hour, it will consume 2000 watts of electricity or 2 kilowatt of electricity. It also means that it requires a 10 ampere socket. Electric sockets are generally of 6 amp or 16 amp. A 6 amp socket will not be able to provide the amount of electricity our AC needs to run. So we need to plug it in a 16 ampere socket from which the AC will draw its required 10 ampere power. Generally, appliances come with plugs which clearly distinguish the socket they belong to. Okay, time for a fun exercise! Go check different appliances in your home and try to figure out their ampere requirement. Match your findings with the plug and socket they are being used in currently. Now what's AC and DC? No, not these, the other ones. AC and DC are 2 types of current movement. Alternating current goes around like waves, such as sound and water waves. Because it flows in the wire like waves, it bounces in the wire, making it lose electricity. While direct current goes in a straight line, it does not rebound, which makes it more efficient than AC. Most of our home appliances run on live electricity. That is, we connect them to the electricity network of our homes, which is connected to the electricity network of the city. That is why, in case of power cut in Indian households, we check the पड़ोसी का घर का बिजली. Batteries are everywhere. In phones, in cars, in laptops and whatnot. By the definition, a battery is an electrochemical device which can be recharged by an electric current and discharged whenever required. So electricity is a chemistry topic? Yes, of course. To further emphasize this, let us start with fruit batteries. It is a simple arrangement where we insert 2 metals, say zinc and copper, inside a lemon and complete the circuit. The team from Royal Society of Chemistry, University of Bath, including battery expert Professor Saiful Islam and science presenter Franz Scott, used 2900 lemons to generate 2300 volts of electricity, breaking the previous world record of 1500 volts. The generated current was used to launch a battery-powered go-kart race, highlighting the importance of energy storage and the need for new innovations for a zero-carbon world. In the market, we usually see these three types of battery. The use and throw ones, the long-lasting one like this Duracell over here, and the chargeable ones which we use for high-end appliances such as digital cameras. The first two are called primary batteries and the last one is called a secondary battery. Now since batteries are products of chemistry, there has to be some difference in the chemical composition of these batteries which makes them apart from each other. Before we understand the difference, let us first understand what is inside a typical battery. Batteries have three main components. One is the electrolyte, for example, water with a spoon of common salt. Second is the cathode, the positive terminal with the ability to attract electrons. Third, the anode, the negative terminal with a desire to push electrons out to become positive. When we connect these three by a medium, say a wire, electrons start traveling from anode to cathode, cathode to electrolyte and back to anode. Remember we discussed circuit in my last video? Now let's understand the difference between the batteries. So let us start with the use and throw ones. These batteries provide direct electric current from the electrochemical reaction between zinc and manganese dioxide or MnO2 in the presence of an electrolyte such as ammonium chloride. Long-lasting batteries do use zinc and manganese dioxide. The major difference is the use of alkaline electrolyte such as potassium hydroxide. And the secondary batteries use more efficient and costlier elements as nickel cadmium, nickel metal hydride, lithium ion and so on. Now let's seek example of this power bank which is basically a big battery. It says 20,000 mAh or milliampere. As 1 milli is a 1,000 part of a SI unit, 1,000 mAh means 1 ampere and 20,000 mAh means 20 ampere. My mom's phone battery is 3100 mAh which means 3.1 ampere. So this power bank should be able to recharge my mom's phone for about 6 times. Now let's talk about the charging time. The output and input of this power bank is 3.6 ampere and 2 ampere respectively. This essentially means that this power bank can release about 3.6 ampere of electricity in an hour, that is the output. So this power bank can fully charge my mom's phone in less than an hour. When we charge this power bank, that's when input comes into picture. The capacity to take in the electricity is just 2 amp. This is a usual case and the main reason why power banks charge your phones faster but get themselves charged at a slow rate. Time for fun exercise 2. This power bank has a capacity of 20,000 mAh and input capacity of 2 ampere, whereas this charger has an output of 1000 mAh. How much time will this charger take to fully charge this power bank? What would be the time taken if the output of this charger is increased to 2000 mAh and 3000 mAh? So that was it for today. We learned about the units of electricity, what they mean in context of our appliances. We learned about the mushrooms of electricity, that is, the batteries, their types, their chemical compositions, and found out how many times a power bank can recharge our parents' phones. We will meet shortly again to discuss some more interesting topics. Till then, you may consider reading my first book. Alicorn Science. The book is about a sweet girl Astrid, her magical friend Ellie, and their approach to their problems. The book was published on 26th of December 2021 and is available on major e-commerce platforms like Amazon and Flipkart. Also, please like this video, subscribe to my channel and share this video with your family and friends. Till then, take care and be awesome like the light. Bye! So, we check the पड़ोसी का घर का बिजली